A quadcopter, also called a quadrotor helicopter, quadrotor, is a multirotor helicopter that is lifted and propelled by 4 rotors. Quadcopters are classified as rotorcraft, as opposed to fixed-wing aircraft, because their lift is generated by a set of rotors. Unlike most helicopters, quadcopters use 2 sets of identical fixed-pitched propellers, 2 clockwise and 2 counter-clockwise. These use variation of RPM to control lift and torque. Control of vehicle motion is achieved by altering the rotation rate of one or more rotor discs, thereby changing its torque load and thrust lift characteristics. Early in the history of flight, quadcopter configurations were seen as possible solutions to some of the persistent problems in vertical flight. Torque-induced control issues can be eliminated by counter-rotation, and the relatively short blades are much easier to construct. A number of MAN designs appeared in the 1920s and 1930s. These vehicles were among the first successful heavier-than-air vertical takeoff and landing vehicles. However, early prototypes suffered from poor performance, and latter prototypes required too much pilot workload, due to poor stability augmentation and limited control authority. More recently, quadcopter designs have become popular in unmanned aerial vehicle research. These vehicles use an electronic control system and electronic sensors to stabilize the aircraft. With their small size and agile maneuverability, these quadcopters can be flown indoors as well as outdoors. There are several advantages to quadcopters over comparably scaled helicopters. First, quadcopters do not require mechanical linkages to vary the rotor blade pitch angle as they spin. This simplifies the design and maintenance of the vehicle. Second, the use of 4 rotors allows each individual rotor to have a smaller diameter than the equivalent helicopter rotor, allowing them to possess less kinetic energy during flight. This reduces the damage caused should the rotors hit anything. For small-scale UAVs, this makes the vehicle safer for close interaction. Some small-scale quadcopters have frames that enclose the rotors, permitting flights through more challenging environments, with lower risk of damaging the vehicle or its surroundings. Due to their ease of both construction and control, quadcopter aircraft are frequently used as amateur model aircraft projects. History: early attempts. Breguet-Richet gyroplane, a 4-rotor helicopter designed by Louis Breguet. This was the first rotary wing aircraft to lift itself off the ground, although only in tethered flight at an altitude of a few feet. In 1908 it was reported as having flown several times, although details are sparse. Ouémecon No. 2, Etienne Ouémecon experimented with rotorcraft designs in the 1920s. Among the 6 designs he tried, his helicopter No. 2 had 4 rotors and 8 propellers, all driven by a single engine. The Ouémecon No. 2 used a steel tube frame, with 2 bladed rotors at the ends of the 4 arms. The angle of these blades could be varied by warping. 5 of the propellers, spinning in the horizontal plane, stabilized the machine laterally. Another propeller was mounted at the nose for steering. The remaining pair of propellers were for forward propulsion. The aircraft exhibited a considerable degree of stability and controllability for its time, and made more than 1,000 test flights during the middle 1920s. By 1923 it was able to remain airborne for several minutes at a time, and on April 14, 1924 it established the first ever FAI distance record for helicopters of 360 am. It demonstrated the ability to complete a circular course, and later, it completed the first 1-kilometer closed-circuit flight by a rotorcraft. De Bethesat helicopter. Dr. George de Bethesat and Ivan Jerome developed this aircraft, with 6 bladed rotors at the end of an X-shaped structure. 2 small propellers with variable pitch were used for thrust and yaw control. The vehicle used collective pitch control. Built by the U.S. Air Service, it made its first flight in October 1922. About 100 flights were made by the end of 1923. The highest it ever reached was about 5 am. Although demonstrating feasibility, it was underpowered, unresponsive, mechanically complex and susceptible to reliability problems. Pilot workload was too high during hover to attempt lateral motion. Convertoring's Model A quadrotor, This unique helicopter was intended to be the prototype for a line of much larger civil and military quadrotor helicopters. The design featured two engines driving four rotors through a system of V-belts. No tail rotor was needed and control was obtained by varying the thrust between rotors. Flown successfully many times in the mid-1950s, this helicopter proved the quadrotor design, and it was also the first four-rotor helicopter to demonstrate successful forward flight. Due to a lack of orders for commercial or military versions, however, the project was terminated. Convertorings proposed a Model E that would have a maximum weight of 42,000 lb with a payload of 10,900 lb over 300 miles and at up to 173 mph. Curtiss-Wright VZ-7. The Curtiss-Wright VZ-7 was a VTOL aircraft designed by the Curtiss-Wright Company for the U.S. Army. The VZ-7 was controlled by changing the thrust of each of the four propellers. Recent developments: in the last few decades, small-scale unmanned aerial vehicles have become more commonly used for many applications. The need for aircraft with greater maneuverability and hovering ability has led to current rise in quadcopter research. The four-rotor design allows quadcopters to be relatively simple in design yet highly reliable and maneuverable. Cutting-edge research is continuing to increase the viability of quadcopters by making advances in multi-craft communication, environment exploration, and maneuverability. If all of these developing qualities can be combined together, quadcopters would be capable of advanced autonomous missions that are currently not possible with any other vehicle. Some current programs include, the Bell-Boeing quad-tilt-rotor concept takes the fixed quadcopter concept further by combining it with a tilt-rotor concept for a proposed C-130-sized military transport. Aeromatica Spas Antius is the first rotary wing RPA to have obtained official permission to fly in the civil airspace, by the Italian Civil Aviation Authority, and will be the first able to work in non-segregated airspace. AeroQuad and Quadcopter are open-source hardware and software projects based on Arduino for the DIY construction of quadcopters. Parrot AR Drone is a small radio-controlled quadcopter with cameras attached to it built by Parrot SA, designed to be controllable by smartphones or tablet devices. Uses: research platform. Quadcopters are a useful tool for university researchers to test and evaluate new ideas in a number of different fields, including flight control theory, navigation, real-time systems, and robotics. In recent years, many universities have shown quadcopters performing increasingly complex aerial maneuvers. Swarms of quadcopters can hover in mid-air, in formation, autonomously perform complex flying routines such as flips, darting through hula hoops and organizing themselves to fly through windows as a group. There are numerous advantages to using quadcopters as versatile test platforms. They are relatively cheap, available in a variety of sizes, and their simple mechanical design means that they can be built and maintained by amateurs. Due to the multidisciplinary nature of operating a quadcopter, academics from a number of fields need to work together in order to make significant improvements to the way quadcopters perform. Quadcopter projects are typically collaborations between computer science, electrical engineering and mechanical engineering specialists. Because they're so maneuverable, quadcopters could be useful in all kinds of situations and environments. Quadcopters capable of autonomous flight could help remove the need for people to put themselves in any number of dangerous positions. This is a prime reason that research interest has been increasing over the years. There are some world-class engineering research laboratories currently developing more advanced control techniques and applications for quadcopters. These include mainly MIT's Aerospace Controls Lab, ETH's Flying Machine Arena, and University of Pennsylvania's General Robotics, Automation, Sensing and Perception Lab. Military and law enforcement. Quadcopter unmanned aerial vehicles are used for surveillance and reconnaissance by military and law enforcement agencies, as well as search and rescue missions in urban environments. One such example is the Aryan Scout, created by Canadian company Aryan Labs, which is a small UAV that can quietly hover in place and use a camera to observe people and objects on the ground. The company claims that the machine played a key role in a drug bust in Central America by providing visual surveillance of a drug trafficker's compound deep in the jungle. Commercial use. The largest use of quadcopters in the USA has been in the field of aerial imagery. Quadcopter UAVs are suitable for this job because of their autonomous nature and huge cost savings. In the USA, the legality of the use of remotely controlled aircraft for commercial purposes has been a matter of debate. The FAA's stance from 2006 has been that such commercial activity is illegal. However, on March 6, 2014, in a court case between PCA and the FAA, a judge ruled against the FAA's claims, effectively affirming that model aircraft are not covered by the FAA rules. In December 2013, the Deutsche Post gathered international media attention with the project Quadcopter, in which the company tested the shipment of medical products by drone delivery. Using a microdrone's MD-4-1000 quadrocopter packages were flown from a pharmacy across the Rhine River. It was the first civilian package delivery via drones. Flight control. Each rotor produces both a thrust and torque about our center of rotation, as well as a drag force opposite to the vehicle's direction of flight. If all rotors are spinning at the same angular velocity, with rotors 1 and 3 rotating clockwise and rotors 2 and 4 counterclockwise, the net aerodynamic torque, and hence the angular acceleration about the yaw axis, is exactly zero, which implies that the yaw stabilizing rotor of conventional helicopters is not needed. Yaw is induced by mismatching the balance and aerodynamic torques. Vortex ring state. Small quadcopters are subject to normal rotorcraft aerodynamics, including vortex ring state. Mechanical. The main mechanical components needed for construction are the frame, propellers, and the electric motors. For best performance and simplest control algorithms, the motors and propellers should be placed equidistant. Recently, carbon fiber composites have become popular due to their lightweight and structural stiffness. The electrical components needed to construct a working quadcopter are similar to those needed for a modern RC helicopter. They are the electronic speed control module, onboard computer or controller board, and battery. Typically, a hobby transmitter is also used to allow for human input. Autonomous flight. Quadcopters and other multicopters often can fly autonomously. Many modern flight controllers use software that allows the user to mark waypoints on a map, to which the quadcopter will fly and perform tasks, such as landing or gaining altitude. Other flight applications include crowd control between several quadcopters, where visual data from the device is used to predict where the crowd will move next and in turn direct the quadcopter to the next corresponding waypoint. See also, Aero Low Atlas, Breguet Research Aeroplane, multirotor, unmanned aerial vehicle, notes. References. External links, ETH Zurich Research on Quadrotors, Up and Grasp Laboratory, TED Raffaello D'Andrea, The Astounding Athletic Power of Quadcopters.